Alright guys, I'm going to go over another sample problem from 3-3, and I'm going to move on to 3-4, okay? So we continued off with finding horizontal tangents, and now we're going to find an equation. So this type of problem is going to be number 37 in page 126. So find an equation of a line that is perpendicular, to the tangent of a curve. So your example would be number 37. This example is going to be number 37 on page 126 of your book. So the curve we're dealing with is y is equal to x cubed minus 3x plus 1. And the point we're looking at specifically is 2, 3. So we got to find an equation of a line that is perpendicular to the tangent of the curve. So when I see tangent, I think immediately derivative. And the derivative at this point. So what it's basically saying, let me focus this really quick. It's probably annoying for a lot of you guys watching this. So just imagine I have this curve. I don't know what it does like that, right? And at 2, 3, right here, we're trying to find, there's a derivative, right? That's the slope at that one point. We have to find the equation for a line that is perpendicular to that, okay? I don't know what that's going to look like. So we're going to find that out. So first, what I would say is find the derivative at this particular point, 2, 3. First, let's do that first. So first step would be to do dy over dx. So this is the derivative of y with respect to x. What that's going to look like is a derivative of this guy, x to the third minus 3x plus 1. If you're wondering how I want you to write this, because it seems like sometimes I do this, sometimes I don't. All you need to do is you can just launch, if you do that, you can just launch right into the derivative, which would be 3x squared minus 3x plus 0. You can skip that middle part and just write that. That's fine. I understand what you're doing there. But if you want to know the notation, what it is the derivative of y with respect to x. That's the derivative of y, the equation. Y is equal to this. So you substitute in y with this. Does that make sense? With respect to the fact that you're taking the derivative with the knowledge that x is the variable that you can plug in stuff, okay? The input value, the input variable, okay? And then basically this is the derivative. It's going to be simplified to 3x squared minus 3x. Let's see. Okay, and this is basically, this general formula is going to give me the derivative at any point. At any point. Okay, at any point. So I want to find the derivative at x equals 2, 3, but in this equation here, I don't really need to do much except just plug in x. Remember, this is not y is equal to 3x squared minus 3x. This is now dy over dx. So you don't plug in y at all. There's no place for you to plug in y. This just tells you the derivative, the slope at that one point. So you only plug in x. So it's going to be 3 times 2 squared minus 3 times 2, which is going to be 3 times 4 minus 6, which is going to be 6, I believe, right? No, did I do that wrong? See, it's 3 times 2 is 3, 3 times 4 is 12. Wait, I feel like I did something wrong here. Give me 1 sec. Oh, you know what it is, guys? I wrote this wrong. Sorry, you guys probably caught this. It's 3x squared minus 3. So it's 3x squared minus 3. This is 3x squared minus 3. This is not 3 times 2, it's just 3. And this should be 9, okay? So that's my slope. That's my slope at that one point, okay? So if you think about the derivative or slope at that one point, another way of thinking about it is like the slope of that, right? That's great, but I want to find the slope of the perpendicular line. So it's like the negative reciprocal of this. So the new slope's going to be negative 1 over 9. Okay, and I want to find the equation for this line. So if you remember, the equation for lines is going to be y minus y1 is equal to m times x minus x1. I have my new slope. Let's get rid of this little prompt thing right here. I have my new slope, which is this, negative 1 over 9. We can start plugging stuff in. X is just a general x. X1 is the point. let's use the 2 comma 3 point. So 2, and then y is going to be y minus 3. So you can leave it like that, or I think most people like you to do all the work. So it's going to be 19x minus 2 over 9, just minus plus 2 over 9, right? And then if I want to start combining these guys, I'm going to have to make him into a fraction that goes over 9. So that'd be times 9 over 9. So that'd be y is equal to 27 over, y minus 27 over 9 is equal to 1 over negative 1 over 9x plus 2 over 9. And then we're going to add 27 over 9 to both sides. So we're going to have y is equal to, this simplifies to negative x over 9, so you might see this in your textbook for your solutions, plus 29 over 9. That's it. Okay? That is the equation for this line that is perpendicular to that tangent point. Okay? All right. That's it. We're going to go on to 3.4 in the next video. Thank you, guys.